Hello students, let's go into a new subtopic, dipole moment and bond polarity. But before that, let us recap on what electronegativity is. Now, electronegativity is the ability of an atom to attract electrons from other atoms towards it to form a bond. Now, if you look at the periodic table, you will notice that the electronegativity actually increases across a row. Now, why is that? This is because the positive charge in the nucleus increases from left to right. Now, if you go down the periodic table, the electronegativity decreases. This is because the atomic radius increases, pushing the valence electrons further from the nucleus, which makes it harder to attract electrons from other atoms towards it. Now, electronegativity can be used to estimate the character of a chemical bond, whether it's polar or non-polar bond. When comparing two different elements, normally one is more electronegative if it attracts electrons towards itself, while the other will be more electropositive if it gives up electron to the other element. As I mentioned before, the bond formed between two atoms can either be polar or non-polar. Whenever two atoms form a bond, the electrons in the bond can either be equally shared or unequally shared. If the electrons are equally shared, then the bond is considered a non-polar covalent bond. A very good example would be the hydrogen gas and also the chlorine gas. Since the atoms are identical, the electrons in the bond are shared equally, resulting in a non-polar covalent bond. Other example includes bromine gas and also iodine gas. If electrons in a bond are not equally shared, then it is known as a polar covalent bond and is said to have a separation of charge or a dipole. The unequal sharing of electrons will lead to partial electrical charges on atoms and is shown by the Greek letter delta positive or delta negative. A good example is a bond formed between hydrogen and chlorine or hydrochloric acid. Chlorine is more electronegative than hydrogen. Therefore, electrons in the bond is pulled more towards chlorine than hydrogen. Now, what you can see here is the Pauling scale. The Pauling scale is a numerical scale that shows the electronegativity of an element. The values range from 0 up until 4. The bigger the value, the stronger the electronegativity of that element. The difference in electronegativity value will tell us whether a bond is polar or non-polar. When the difference in electronegativity between two bonded atoms is 0.4 or below than that, according to the Pauling scale, it means that the electrons are equally shared. Therefore, the bond is considered as a non-polar covalent bond. For example, the CH bond. The CH bond is considered non-polar. This is because the difference in electronegativity is 0.4. Now, if the difference is between 0.4 to 1.9, then the electrons are not equally shared and it's said to have a separation of charge. This bond is therefore considered as a polar covalent bond. Presence of bond dipole or dipole moment can be shown using the cross arrow. Now, how do you do this? You can do this by drawing the head of the arrow facing towards the negative end, while the cross on the tail will face towards the positive end. Now, down here is a very good example. The bond between hydrogen and fluorine is polar. The electrons shared between the both atoms are pulling more towards the fluorine. Therefore, fluorine is considered the electron-rich region. whereas the hydrogen will be the electron poor region. Right, just now we look at bond polarity and how to determine the polarity of a bond. Now let's look at molecule polarity. Now what's the difference between bond polarity and also molecule polarity? So for bond polarity, we actually look at the difference in electronegativity between two atoms sharing in a bond. Now to determine the molecule's polarity, we actually must consider the geometry of the molecule as a whole. Okay, for example, you have carbon dioxide. Now, carbon dioxide, the CO bond is actually polar. Why? Because oxygen is more electronegative than carbon, and the difference in electronegativity is 1. The carbon dioxide molecule, however, is actually non-polar. Now, why is that? Okay, so if you look at the whole geometry of carbon dioxide, now carbon dioxide actually has a linear geometry. And so the electrons shared between the carbon and oxygen is actually pulling towards opposite direction. One is pulling towards the right side, the other one is pulling towards the left side. Okay, and so the bond dipole cancel out each other. Okay, left, one is pulling to the left, one is pulling to the right, so it cancel out each other. Therefore, the overall dipole moment is actually 0. Okay, there is no separation of charge. And because of that, carbon dioxide molecule is non-polar. Now, let us look at another example, which is the water molecule. So on the left here would be your water molecule. Now you can see that the OH bond is polar. Why? Because oxygen is more electronegative than hydrogen. Now if you calculate the difference in electronegativity, it is actually 1.4. Now the whole molecule of the water is also polar. Now why is that? Okay, so if you draw the geometry of your water molecule, you will notice it has a band or V shape, something like this. Okay, now the electrons shared between the OH is pulling towards the oxygen. So all of it is pulling towards the oxygen. Now due to the geometry, the top part, okay, the top part of the molecule, the water molecule is electron rich because all of the electrons is pulling towards the top part while the bottom part is electropositive. Okay, now due to this, due to the separation of charge, above is more electronegative, below is more electropositive, there is a separation of charge which makes the whole water molecule polar. Now here are examples of different molecules having different molecule polarity. Now it doesn't mean that if a bond is polar, the whole molecule will be polar. Okay, it really depends on the geometry of the molecule as well as whether it has overall dipole moment or not. So here are the steps for you to determine the polarity of a molecule. Firstly, draw the Lewis structure and determine the number of bonding pairs, lone pairs, and total electron pairs. Then, determine the molecule's geometry. Refer to the previous subtopic that I've given you. Third, determine the bond polarity and draw the dipole direction using the cross arrow for every bond that is present. And lastly, consider the whole geometry and overall dipole moment, if any, when determining the molecule's polarity. That's all for this subtopic. See you in the next one. Bye everyone.